Hey Royals, in this lesson we're going to look at scatterplots and correlation. And before we get too far into the lesson, let's just review a couple terms. Now, a variable is something that can be measured, and we say it's an attribute that can be measured. So anytime I use the word attribute, we're just kind of thinking about something that can be used as a variable. Okay, so a one variable data set involves just simply one attribute, one thing that we're measuring about the person or the object. So it might just simply be, the eye color or their height or what grade they're in. These are just simply one piece of information about the person or the object. So we could put them on, say, a bar graph or a histogram or a circle graph. This is all stuff that we've been looking at already in this unit. Now, when we try to take two pieces of information, we call it a two variable data set. And that means that we're measuring two attributes or two things about the person or the object. And we put them on the same graph together. So that might mean that we're measuring the eye color and the hair color of the person. Or we might be measuring, the height and weight, both at the same time. Or lastly here, then how about the grade and their gender? So what grade are they in and what gender do they identify with? Okay, so what we're going to try to do right now is we're going to try to read a statement and determine if it is a one variable data set or if it's a two variable data set. And how we do that is if we read it and we say, hey, there's only one piece of information in this statement, then obviously it would be just a single one variable data set. But if there's two things being measured together, that tells us immediately that we're dealing with a two variable data set. So the first example here says Lucas conducts an experiment where he records the number of speeding tickets. So that's one thing that he's measuring, number of speeding tickets issued in a given year, along with the average price of gasoline. So you can see that when we saw along with means that there's going to be two pieces of information. And the fact that I have the recorded number of speeding tickets and the average price of gasoline together means that we're dealing with a two variable data set. Okay, so let's try another one here. So it says Lee conducts an experiment where she records the height of all NBA players on the Miami Heat roster in 2014. Now, we're only measuring the height of the NBA players in one given year. So that tells me immediately that we're only looking at one piece of information. How tall they are they? Right, so we're going to have just a one variable data set. Okay, so what I want you to try here is pause this video, see if you can read through C and D and determine if they are a single data set or a single variable data set or a two variable data set. So welcome back. I went ahead and I solved both of those problems. So in C, we were only looking at the selling price of homes in one neighborhood. So that told us that we were only dealing with one piece of information. So it would be a one data set. And in D, we were looking at the number of times a person works out and that person's weight. So we are going to put that information together, which means that we have two pieces of information. So it's a two variable data set. So a couple things that we need to remember here is that if we are using a one variable data set, there's a series of graphs or pictorial ways of showing this information. And we've already talked about these. There's the bar graphs, the circle graphs, the pictographs, all use discrete or categorical data. And another graph that we've been working with is called a histogram, and it is entirely used for continuous data. And these are just for one variable data sets. Now, if we get these two variable data sets, it opens up a new type of graph. And this graph is called a scatterplot. And that's what we're going to focus on in this lesson. And with these types of graphs, we're going to have what's called an XY axis. And often in grade 9, we call these linear relations. Okay, so let's dive into what a scatterplot is. It's a way to show these two variable data sets. that we actually have two variables that we're going to be using. And we can make predictions based off of these graphs. And that's going to be really, really helpful for us. And we have something called an outlier. An outlier is a point that might show up on these graphs that just doesn't follow the trend. It kind of stands out, right? So if we were looking at the graph below, you can see that there's one point that's kind of sticking out like a sore thumb. And we'll get to that point, that's this one, as we move through this first example. Okay, so one thing I did mention is that when we have these scatter plots, we can start making predictions from them, or talking about how the trend or how the graph is changing. Okay, and one way that we do this is kind of through a sentence. So A part has us working on those types of sentences. It says, as the time studied increases, and that involves us taking a peek at the graph. So where does time studied show up? Well, that's right here. And if it's increasing, that means we're moving towards the right. So as we move towards the right on my graph, how do the test scores, that's what's on my vertical axis, the up and down axis, how do the test scores change? So as I move left, how do my test scores change? Well, that looks like they're going upwards, doesn't it? It looks like they're kind of going in this direction. So I would say that as the time studied increases, the test scores also increase. So let's put the word increase here. And so let's describe this pattern. So what pattern do we see? Well, it looks like, the data goes up to the right. So that's the pattern that I see. I'm seeing that the data points seem to be increasing as we move to the right on my graph. Now there's a point here that we want to investigate, and this point is at 2 hours. So what we're going to do is we're going to go to 2 hours on my graph. That's right there. For the time studied is 2. And we're going to go straight up until we run into a data point right there. And now what we're going to do is we're going to move straight over to the vertical axis to find out where are we. And I think right there would be about 55%, because we're talking about out of 100. So we're dealing with percentages. So identify the point where we have 2 hours and a 55% average. That's this point right there. So we say it's 2 on this first axis that we went with, and then 55 on the up and down axis, the second axis that we worked to. Now let's identify another point somewhere on the graph. Let's say we want to pick this point right here. So we always move left and right first. So let's figure out how far we went along the horizontal or the x-axis. So here I have 6. If I go right up from 6, I run straight into that point. So we have that our point, second point, let's put it here. Second point is at 6 hours. And now let's figure out where it crosses on our vertical axis, the up and down axis. It's at 80. So what does that mean? That means if 6 hours studied, we get an 80% average. Okay. So at 6 hours studied, we get 80% average overall. Now, this is an example problem. It doesn't mean that the more you study, the higher your average. It's just the example that we have here on this graph. Now, I mentioned that an outlier is a point that just doesn't follow the trend at all. So we want to look at the graph and see if there's any points that just don't follow this trend or follow the line. And you see the line that we had was this one right here. Is there any points that just are really, really far away? I think we've already identified this point. It's right down here, right? That's our outlier. So let's identify what it is. It's 7 hours studied. studied gets a 20% overall average. Yikes, that's not good. So what could possibly be an explanation for this outlier? Well, one that comes to mind for me is maybe they were studying for the wrong test. Maybe this was supposed to be a math test and they were studying for their English test or geography test. So that might be an explanation of why if I study for 7 hours, I might only get 20% on a test. Right? So we could put here, maybe they studied for the wrong class. That's one possibility. Or maybe another one might be that they did in fact study for 7 hours, but they were distracted with TV or their siblings or their cell phone, their TikTok, whatever it is, and really they were not effective for that 7 hours that they were studying. Okay, so let's look at the next question here. It says, if someone studied for 4 hours, okay, so let's go to the graph and look at 4 hours, and let's go up here at 4 hours studied. That's right here, and I'll use a different color here. How about we use, I don't know if I've used green on the actual graph. So there's green. At 4 hours, if I go straight up, do I run into a point? I keep going. Oh, I'm right off the graph. I didn't run into a point. So it says, what average would someone get if they studied for 4 hours? Well, first of all, that's not on our data. We don't have information about that. But we can see that there's a trend here. If I put this line down, it might have a point somewhere in here. So we can kind of guesstimate or make a prediction on what we think their average might be. That might be about 75% if I ran all the way over to that vertical axis, right? So I'm going to put here no data point on graph, but the trend, that's how the line seems to be going through the data, says they should get about 75% overall. Right? And that's us making a prediction. We'll spend more time making predictions in a future lesson here. Okay, so the next question here is, how is two variable data different from one variable data that we've previously studied? How is it different? Now I want you to pause the video right now and talk to someone else in the class about how these types of graphs or these types of data are different than anything we've studied in this unit. So welcome back. I just put in that you have filled in that question with an answer that you had with the discussions from your neighbors. So the next thing that we're going to do, once we've now talked about how we can make these scatter plots and get some information from them, is how can we actually discuss these trends? Like, how is the data changing? And in mathematics, there's a special word for that. It's called correlation. And correlation is the relationship between the two variables. So as we saw in the last example, the more I studied, my mark went up. So that's what we would call a positive correlation. And what do I mean by positive? Well, first of all, there's correlations that can be negative, positive, or there can be something called no correlation at all. And a positive correlation is if I have one variable increase, the other variable increases. So I get something called a positive correlation. So one goes up, the other one goes up. And that's what we saw in our previous example, where if I studied more, I got a higher overall average. Now the next one is a negative correlation. And that one has, when one variable increases, the other one decreases. So that kind of looks like this. If one goes up, the other one goes down. An example for that might be that the time spent studying and the time spent playing video games are negatively correlated. Because if I increase the time that I spend studying, the time I can spend playing video games generally does go down. And so you can see that is one variable goes up, the other variable goes down. And the last one here, what we say is no correlation, or none, if we're talking about correlations, is that there's really no relationship between the two variables, right? So the example that we might have here is that if I was talking about video game scores, if the video game score goes up, it doesn't change the size of your shoe, right? So if you increase your score in your video game, doesn't mean that your foot size changes. So there's really no correlation there. And so let's take an example of this. So if I look at these two graphs here, what we want to do is we want to determine the relationship between the two variables and the type of correlation. So the relationship here, so that as the monthly heating, we always read the horizontal first, as the average temperature increases. So average temperature increases. What does the monthly heating do? So as the temperature increases, as I move towards the right on this graph, I see that my data seems to be coming downwards. So the trend seems to say that it's going downwards. So I'm going to say the heating bill goes down, or decreases, right? We can put the word decreases. So what does that mean? One goes up, this one's going up, this one goes down, which means that we have a negative correlation. Okay, so I want you to pause the video and see if you can replicate this or do this type of approach for that second graph. All right, welcome back. So what I did here was I looked at that horizontal axis, so the one that goes across the bottom, and I said the minutes exercised as I increase, as I move to the right on that graph, what happened to the calories burned? Well, it looked like they also went up. So that was increase as well. So they seem to both do the same thing. And when they both do the same thing, we end up getting what's called a positive correlation. And this is really nice because we can see it visually on the graph. And one skill that we like to have is being able to determine it without having a graph. And for this, we're going to say in general what happens. I know that there might be some specific examples of like, no, I owned a car once that the car price actually did go up the older it was. But we're going to talk about in general, right? So if we took a look at the whole population, what would tend to happen? Okay, so as the number of songs downloaded on my phone, so that's one thing. What happens to the amount of memory available? So I would say that if the number of songs that I download goes up, the amount of memory on my phone decreases. So that's what we're going to say is a negative correlation. Now let's try another one here. So the number of siblings a student has. So the number of siblings a student has and the grade that they have in math class. So if the number of siblings that you have increases, what happens to your grade in math class? Does it go up or does it go down? I don't think it changes. So if it's not going to change, I can kind of put like a horizontal line here if you really wanted to. We can say that there's no correlation. It's not going to change based off of the number of siblings that you have. It doesn't mean that if you have more siblings, your grade in math class goes up. Or if you have less siblings, your math class grade goes up. There's no correlation there. Okay, and how about the last one here? It says the age of a car and the value of that car. So that's how much money that car is worth. So as the age increases, what happens to the value of that car? Well, it tends to go down as well, right? And so we can say here that this would be a negative correlation. Okay, so there we go. We've dealt with how to identify the type of correlation looking at both a graph and in the words. Okay, so one last thing we want to do in this lesson is talk about these independent and dependent variables. Now, independent means that it doesn't depend on anything. I can change it and do whatever I want. Now, dependent, this is tough here. Dependent means that it's forced to change. It depends on something. So if I were to change something, it has to change. Okay, so if I would look at this graph here, and I'd say that the minutes exercised is changed, I'm going to say if I increase it, the number of calories burned has to change, right? It's not like it can just not do anything. It's going to have to do something. And so that's what we mean by independent and dependent. Okay, so I'm going to just change this sentence a little bit. It says, we call the variable being affected the dependent variable. And we call the variable that isn't influenced by anything the independent. Now that's the one I'm going to put here, we can change. It's the one that we have access over. Okay, so I can manipulate it all I want, and I'm then going to find out how does the other variable change because of it. Okay, so we want to decide which of the two variables, now all of these examples are going to have two variables. We want to find out which one's the independent and which one's the dependent variable. Okay, so the temperature outside and the cost of air conditioning. So which one depends on the other? Does the temperature outside depend on the cost of air conditioning, or does the cost of air conditioning depend on the outside temperature? Well, I'm going to say that the cost of the air conditioning is the one that's going to change because of the outside temperature. So here I'm going to say independent is the temperature outside, and the dependent, the one that's going to have to change, is the cost of air conditioning. Okay, let's do another example here together, and then I'll have you try the last two. Okay, so the amount of gasoline you put in your car, so that's one thing that we can change, and the distance that you can travel before your next fill up. Okay, so which one depends on the other? Well, I think the distance that I can go depends on how much gas I have, right? So I'm going to say the distance that you can travel is going to be my dependent variable, and the amount of gasoline that I put in my car is my independent variable. So I'm just going to put here that this is my independent. Oops, let's fix that. Independent variable, and this would be my dependent variable. All right, so now it's your turn. Try to solve C and D, identifying the independent variable and dependent variable based off of what we just did. Welcome back. So let's take a look at C and D. So the number of cups that Emily sells, I would say, is the thing that we could change. If she sells more, she's going to make more, right? So the amount of money that she earns depends on how many cups of lemonade she sells. And then the last one there is kind of flipped on us, right? So the G force, so the amount of gravity force that we experience depends on how fast that fighter jet is flying, or the jet is flying. Okay, so we can see that there is a relationship between the speed of the airplane and how much force I experience. The faster I go, more force. Okay, so one last thing here about independent and dependent variables. If we're looking at a table of values, and that's the type of thing where we see kind of like, I don't know, X and Y, or it might be something like speed and G-force, and I can change my values. So let's say like 1, and this might be 5, and 2, and might be 10, and it might be 3 and 15. The independent variable is located on the X. So it's always on the left side of that table. So we're going to say the left side of that table. Whereas the dependent variable, that's the one on the right, will always be on the right side of our table of values. Now, if we have a graph, and I wanted to graph this, my independent variable always goes on the bottom. So that would be my speed, and this might be my G-force. Right? So we see that on the graph, our independent variable is always on what we call the x-axis. That's the horizontal axis. So I'll put the x-axis, or horizontal. And the y-axis, or the vertical axis, always has our dependent. So I'm going to say the y-axis, or the vertical axis, will always have the dependent variable. Now, a couple variables that typically are almost always independent variables are things like time. So if you have time in your measurements, it's 99.9% of the time on the horizontal or x-axis. And same thing with temperature. So if you run into a question that has temperature, chances are temperature is going to be your independent variable. All right, so this was our lesson on scatter plots and correlation. We also threw in a little bit of a discussion on independent and dependent variables. And I'm going to suggest now that we jump into trying some of your check your understandings questions. And if you have any questions yourself, you can feel free to send me an email.